Just out of curiosity, how many people are familiar with domestic energy storage by a show of hands? Okay, most people, most people. So this is hopefully not new information. Uh, as they mentioned, I am Tobi Babalola. I work for UK Power Networks in the innovation team. And I'll be speaking very briefly on domestic storage as a service to distribution network operator. As the map shows, we are the distribution network operator for the southeast of England, which means we maintain the cables, the transformers, and other devices that bring power to consumers' homes in the southeast of England. We service about 8 million homes, which is about 20 million people in this area. And like I mentioned, I work in the innovation team, and our task is really about looking at research and development in emerging areas. I particularly look after consumer technologies like electric vehicles, small generation, and small storage is increasingly one of those things. So why is battery storage so interesting, and why do most of us know about it today? Well, I think there's a few reasons why. The first thing is solar PV. On your far left, you'll see that there's about 495 megawatts of installed solar PV capacity, domestic solar PV capacity in UK Power Networks area alone. And that's in the last 10 years. And this interest is one of the things that's leading consumers to think about energy storage, coupled with the fact that the domestic feed-in tariff, which is the payments, the subsidy that people with solar PV have been getting, is reducing significantly. They are now looking to energy storage to maximizing their consumption of their solar PV. Therefore, they can import less from the grid and pay less to the electricity suppliers, and therefore maximizing the investment that they've made in their solar PV. So this shift is really increasing the interest in domestic storage. The other thing is electric vehicles. They use batteries, and we're seeing more and more electric vehicles on the road, which means that the increase in the production of batteries is driving down the cost of domestic storage. And that will only continue to be the case as we see more electric vehicles on the road. So the cost of storage will go down, and it will mean that it's more an attractive proposition for customers. We have people like Tesla and their Gigafactory, who are vastly increasing the number and the volume of storage that is being produced in the world, which again will drive down cost and drive down the interest in consumers. Also, they have fantastic propositions that make it look attractive, they make it look appealing. And the final thing is, of course, money, economics. It just makes sense to get domestic storage more and more as the costs go down. Why? Because as I mentioned, in the domestic storage context, you can maximize your own generation and therefore import less from the grid, therefore saving yourself some money. Not only that, people are considering aggregating a number of domestic storage devices into a pool similar to a virtual power plant to offer services back to companies like not mine, UK Power Networks, National Grid, and generators, suppliers, etc., therefore giving them additional revenue streams, which again just makes the economic case for domestic storage even more improved. So with all this said, domestic energy storage can really double if we assume that everyone who's got solar PV now takes up a domestic storage that's similar size to what they have in terms of solar PV today. It could double the amount of generation that we have on our networks from properties. That's significant. Not only are consumers interested, this chart shows the interest in energy storage connections at a grid scale, so that's extremely high voltage, on our network in the last just over a year. And this is on the back of National Grid's enhanced frequency response tender. And you can see that there's 12 gigawatts of interest by the end of, just by the start of 2017 this year. 12 gigawatts. That compares to our current peak demand on our entire network of 16 gigawatts. So if you're talking about potentially 12 gigawatts of storage in general on our system, in effect, you might see a scenario where we don't need generation from perhaps nuclear or coal because we've got energy storage meeting our demands. It's very significant. And this, to emphasize, is just on UK Power Networks area alone. Obviously, people are interested in energy storage right across the UK. So why are we interested in energy storage as a distribution network operator? Well, the first thing is keeping the lights on. We supply electricity to all those customers I mentioned earlier, and domestic energy storage offers us an additional tool to be able to maintain those supplies to customers. Another thing is keeping electricity bills lower. One of the things that we do as a company is we invest in our network, particularly in response to the increasing demand on that network. energy storage can see a reduction in that demand, or at least a leveling off of that demand, because consumers are meeting their demands locally using their own energy supplies, which will translate into cheaper bills for them, and we don't have to invest as much in our network, which eventually goes to the customers in their bills. So we're keen to obviously support energy storage to empower the consumer and also to make sure their bills are cheaper. Finally, it's really about facilitating low carbon. We all know that renewable generation is intermittent in its nature. The wind doesn't always blow, the sun doesn't always shine, or indeed when the wind is blowing and the sun is shining, consumers' demand might not match that. So energy storage allows us to store that and use it when the wind is not blowing, and use it when the sun's not shining. So that effective efficiency is something that we're keen to support because it reduces the carbon footprint in our area. Interestingly, we traditionally, as a network operator, take power from a central source and send it, transmit it, distribute it down to consumers. It's quite a one-way stream. More and more we're seeing that stream is more dynamic, it's more active in its nature. What does that mean? It means that with people installing solar PV on their roofs, with more wind generation on the system, and so on, we're seeing that energy is going both ways now. And so we have to be more dynamic in the way that we manage our networks. And this means that we are transitioning from a passive distribution network operator to a more active distribution system operator. And this is a role that we're effectively fulfilling already, but we will only continue to see that mature as we go into the future. And energy storage allows us the flexibility, because you can charge it when you want, discharge it when you want, to play a more active role in this DSO future. And that's another reason why we're interested in energy storage. So what have we learned about energy storage today? We've done a trial, the SNS project, which stands for Smarter Network Storage, otherwise known as the Latent Buzzard Storage Project or the Big Battery Project, some of you may be familiar with. It is a 10 megawatt hour, 6 megawatt installation, which you will have seen on the cover of my presentation. It's about the size of 2 tennis courts, and we have batteries in there that offer us a service on that particular piece of network. We've learned a lot from that project, which ran for about 4 years, about how to manage constraints on our network, how to offer and play in the flexibility service market with National Grid. We've learned about managing voltage issues and power quality issues. So we've already, in some ways, defined the case, established the case for energy storage. So now what we're saying is, how can we transfer that to consumers? So we didn't stop at that project. We are continuing to make sure that we play an active role in facilitating battery energy storage. We're doing that through enabling, empowering our customers through surgeries. We're doing that through publishing guidance documents and heat maps, so that large developers, for example, who are interested in what parts of our network is their capacity to install these big storage projects, they can quickly make that decision. And empowering the customer means that they can connect quicker and offer these services back to us as consumers. Another thing which I'll be speaking on, just following from the slide, is the Domestic Energy Storage and Control Project, which is effectively the small baby of the bigger battery project. This is looking at 60 consumer properties, and I'll come into the details on the next slide. So this is effectively saying we are continuing to ensure that we are actively working to make sure energy storage plays its part in how we operate as a business and how consumers actually want to operate. So the DESK project, as I like to call it, is an 18-month project looking at 60 storage devices in people's homes across our network. We're looking at both alternating current devices and direct current devices, and we're looking to do an active control trial in the middle of that. So that is where we change the behavior of the battery storage so that we can see how the flexibility services that we think that they can offer actually play out into actual benefits to the consumers and to the DNO. The objective of the trial really is threefold. One is to get empirical data so we can support faster and quicker connections to the network operator. One of the reasons why we're really interested in this is because once you start to introduce storage to people's homes, much in the same way as you introduce solar PV, you introduce additional generation. And all of a sudden there's, like I mentioned earlier, electricity potentially going the other way on our network, which we need to be aware about because we need to operate our network safely and securely. So we want to provide the data or monitor and collect the data that helps us to inform how we manage that situation. Another thing is we want to quantify the effect of a home with PV and energy storage. The reason we would want to do that is because when we forecast into the future how much we need to invest on our network, we generally think about what is the trend in demand. Is it going up, is it flattening out, or is it going down? So one of the ways we do that is saying consumers have these different technologies and therefore they will continue to use them and therefore they will use them in this pattern and so on and so on. And so there's a profile that emerges. So we want to profile a property with domestic storage and solar PV to inform that long-term forecasting. Finally, we want to really quantify what is the value of this flexible, aggregated approach to managing individual domestic storage devices in many people's homes to offer a service back to us at a level on the network that it's beneficial to us. We're doing that by monitoring and gathering data. We're doing that by analyzing the data with Imperial College London over the 12 months that we will be getting that data. And finally, like I mentioned, we will be alternating the operational mode of the storage devices in people's homes to see if you operate it differently, is there more benefit or less benefit from one mode of operation to the next. And finally, what will come out is engineering recommendations about how can we manage our networks with our improved understanding of how these devices all fit together and work together. What is the profile, like I mentioned, of a consumer with these technologies and how can we use that to inform investment on the network? And finally, what is the role of aggregated active control? So the future of storage is bright. I mean, it offers us all this flexibility, not just at a consumer level, but at a network level and certainly at a system level as well. It's improving because the costs are going down for all the reasons I mentioned earlier, and the experience is getting better. And I think from the interest in this room alone, we can, I think, feel confident that that's going to continue to be the case. And what all this means is that there's an increased focus on energy storage and there's an increased requirement for companies like ours to play an active role in making sure this becomes a reality. So going forward, we are actively seeking already modes of operation, like I mentioned earlier, that mean that we are more of an active player in how power moves and slushes around our network. So to that we are going to the market to ask for flexibility services. One such service is demand-side response, where we can ask somewhere like the Excel to turn down their demand, hopefully not today, so that we can manage the power demand on our network and not have to invest in cables and wires, which might be more expensive for consumers in general, if they can simply offer us that service, and they will get paid for that. It sounds like a win-win to me. We'll continue to collaborate because it's important in what we do. These consumer devices, for example, are exactly that, consumer devices, so we need to think about ways that we interact with those consumers to make sure that we capitalize on these services. That will involve government, our regulator, the system operator, like National Grid, and other players as well. And we will continue to make sure that we're talking to our customers to make sure that we understand what they want as well as what we want and strike a balance there and make sure energy storage plays a role in how UK Power Networks facilitates energy storage in the future. Thank you.